We're going to cover the topic of how strong is seafood nutrition science. And Dr. Tom Brenna will be moderating. He is the chair of the Seafood Nutrition Partnership's Scientific Nutrition Advisory Council. Oh, come on. Oh, you're getting mic'd. Okay. He is professor of Pediatrics, Chemistry, and Nutrition at Dell Medical School at UT Austin. Dr. Joseph Hibbeln is a nutritional psychiatrist, doctor, and former acting chief of NIAAA, also a member of the S&P Scientific Nutrition Advisory Council. Mr. Phil Spiller is former director of seafood at the FDA. And then Dr. Nick Ralston is director of Sage Green with NRG, and it has deep expertise in selenium. So we welcome our panelists today for a lively discussion on how strong is seafood nutrition science.
Okay, very good. I'm going to more or less be a moderator here, and I was thinking that Dr. Carlson had an easier job because she only had to follow Martin Paul. We've got to follow Martin Paul and Dr. Carlson. So you heard today about some of the newer material on omega-3 fatty acids, really kind of specific to that, omega-3s being a component of seafood and seafood being a rich source of omega-3s in general. Here we're going to focus more on seafood nutrition specifically and the strength of the science. And you've got strength of science on omega-3s. We'll now talk about strength of the science on seafood specifically. Our panel today has, oh God, I hadn't even thought about it, just popped into my head to add up all of our collective experience, and we'd be well beyond a century, I think, messing around with this stuff. But I'd like to start talking a little bit about there's a slide advancer somewhere. Thank you very much. Oops, back. Oh, that's us. Okay, there we are. Okay, how strong is the seafood? How strong is the science on seafood nutrition? Now, there is quite a history of science in seafood nutrition, and I'd like to first call upon Philip Spiller, who has been around this field of seafood nutrition as long as anyone, to tell us a little bit about the strength of science and perhaps even the early days of starting with maybe the early days and of advice on seafood and sort of where we've come from and how we got here.
Get this to work. Is it?
It's on.
Am I on? Okay. The early days are roughly around the year 2000 with a report from the National Academy of Sciences where they were asked to by one of the federal agencies, in this case it was EPA, to help them calculate a better, what they call a reference dose for methylmercury, not for seafood per se, but for methylmercury per se. But in so doing, they came to a conclusion which startled a lot of people. It caught us at FDA when I was there at that time quite by surprise, and caused a bit of a sensation to the point of panic, where they said in the intro, 60,000 babies are being born at risk in the United States every year due to methylmercury in seafood. And we found ourselves being barraged with inquiries about, well, what are you doing about it? And the first thing we did was we wrote to the National Academy and we said, what do you mean? Could you please explain what at risk means the way you understand it? And they actually, to their credit, they wrote back to us and they said that in the letter, it was a short letter, but they said they admitted that they had no idea, there was no way for them to know whether there was any harm to occurring to any of these 60,000 babies born a year at risk. But nonetheless, the pressure was on my agency to do something. And so it was decided, since we didn't have any more data than they did, there really was no data on what was the effect of eating seafood on babies' health, particularly on neurodevelopment, because the concern was on neurodevelopment.
And we're in the year 2000 roughly.
We were in the year 2000. So it was decided at FDA that what we would do was issue consumption advice to pregnant women. It's the first time that was thought of. It was as a consequence of the concern about 60,000 babies. And it was decided that the consumption advice would recommend to pregnant women a limitation. Don't eat more than X. And then we had to figure out what X was. And we had, again, with no data, a very data-driven organization, we said there's no scientific basis right now. We don't have the evidence to give an X based on scientific data. So it was decided that it would be done on precaution as a matter of prudence. And we were going to come up with a number. And so it was decided that the number would be 12. And 12 was decided so as not to undermine the American Heart Association's then recommendation not to eat less than or to eat at least 2 servings of seafood per week.
2 servings making 12 ounces, right?
Well, that was our interpretation, not theirs. They just
okay.
said, the American Heart Association said 2 servings. We decided that was going to be 12. So we decided that if they're saying eat that much, we were going to say to pregnant women, but don't eat any more than that.
So what you're saying is that you didn't have the kind of survey of what women were eating and whether their birth outcomes or their children are doing well. You came up with the best number you could, also known as possibly pulling it out of a hat, but it was more or less your best guess.
It was a best guess.
Okay.
Yes, it was.
And so then fast forward a bit, there's been a lot of work done since then, hasn't there?
Yes, that would be an understatement. At that time, when all of this that I'm describing occurred, there was zero. We had no studies, no evidence with regard to seafood consumption eaten as a whole food during pregnancy. To this day, there has been such an incredible avalanche of data of studies being conducted in the United States, in Europe, and in Asia. And by my count, there are now approximately 30, I would say approximately, there are 32 studies that I count. And the total number of mother-child pairs in those studies is now in the ballpark of 300,000. And what I kept looking for was, in any of these studies, did they report harm? Because a lot of times in each one of the cohorts, there are people that eat hardly any seafood. There are people that eat a little bit. And then there are some people that eat a lot, way over what's normally in the United States. And none of these studies are not reporting harm. And sometimes they measure the methylmercury along with the amount of seafood consumed, and the methylmercury is quite high, and they still find no harm. With regard to the benefits, they found a total in those studies, by my count, of 55 times in which eating more seafood was more beneficial than eating less or none for some domain of neurodevelopment, one of the most notable being IQ. And the studies that show benefits to IQ range from a couple of IQ points up to a high of about 6.
Thanks. I'm gonna get Dr. Hibbeln in here to talk about some of these benefits. Dr. Hibbeln's a psychiatrist who has run a research laboratory for many years at the NIAAA, and so and I think you've studied these things.
Yes, and it's critical. I want to make one coda from Phil's comments, and the opposite of benefits is harms, and there is a harm in these studies, and the harm is following the U.S. dietary advice to eat low seafood or eat no seafood. And what we did in 2007 was to test the dietary advice in a population of 15,000 women in England, finding that when women followed the advice and ate little seafood or no seafood, it doubled the risk of low IQ in their children because the advice was solely focused on a theoretical guess of mercury levels and completely ignored brain nutrients and selenium in seafood counts.
So you would call that a key benefit, addressing our second question of seafood consumption for maternal health and baby brain development.
Yes, indeed. With regards to how strong is the science on seafood nutrition, to evaluate this question, we have to look at various levels of science. Epidemiological data across countries, longitudinal studies, biochemistry studies in rodents, and mechanistic studies in rodents, and clinical studies in humans. In summary, my opinion is that the data is consistent for the health benefits of seafood across all of those different levels of analyses, impacting multiple health outcomes from the brain to the heart to the skin to cancer, distilling pretty much in consensus reasonable amounts of seafood and omega-3s that should be consumed.
So we have a third question, which is how much seafood can expectant moms eat? And both of you have addressed this question in your careers. I'll take an answer from either one of you on that question.
I would like to reiterate Phil's findings that in the studies where women ate huge amounts of seafood, well beyond what are advised levels, there was no evidence of harm. And when they ate diets deficient in seafood and low levels, there is evidence of harm, likely due to inadequate intakes of omega-3s. Seafood I describe as a bag of brain nutrients. And we evolved on seafood. When you don't eat it, you become deficient. Can't say exactly the parameter of which nutrient, but seafood deficiency. And you can eat as much as you want.
Maybe Phil can make a comment on that amount.
There have been a number of survey research studies of what pregnant women are eating, amounts that pregnant women are eating. One actually quite recently that shows it's very low. But FDA did one, which there was one before it and one after it, and what FDA did somewhat in the middle, it was around 2010, was reasonably consistent with the one before and one after. And what they showed was that, or what the women surveyed, and it was about 1,000 women, that when they became pregnant, they reduced their consumption down to about 1.8 ounces per week. And they did so out of concern for safety. And in the studies with 300,000 mother-child pairs, their consumption down at that level, there's consumption higher. And at the very high ends are actually somewhat breathtaking. They go up as high as 80, 90, and even as much as 100 ounces a week, which I found rather astounding. I still do. But nonetheless, that's what the studies report, and they are reporting no harm even at those levels. So
that 80, 90, or 100 ounces a week is as contrasted with, let's say, a recommendation of 8 to 12 ounces a week in the United States. So there are places, certainly places in the world that eat a lot more seafood than in the United States. So I want to get my friend Dr. Ralston in here. And now, one of the things that we get questioned on all the time when we're recommending seafood and talking about these kinds of results is, well, what about mercury? Isn't mercury a problem? Too much mercury will be an issue. Now, in 2000, as you just heard, it out of an abundance of caution, you might say, right, well, we better study this. Well, we kind of have studied it, and the one of the leading people studying it is Dr. Ralston. And what can you tell us about mercury and I think selenium's your favorite element?
Well, yeah, you could say that. I've been working on selenium for the past 30 years. Started off doing selenium as a nutrient, And it's hugely important in the brain. It turns out that it prevents and reverses oxidative damage, especially in tissues such as the brain, which are rich in polyunsaturated fatty acids and consume a lot of oxygen, so there's potential for damage. It turns out there's nothing in the world that can stop your brain from having the selenium it needs except one thing. I bet you can guess what that is. Mercury. Mercury has a huge binding affinity for selenium. If you get too much mercury, it will bind your selenium, and those lovely enzymes that are supposed to protect and reverse oxidative damage in your brain and your endocrine tissues, in your heart, throughout the body, those enzymes will cease working. And guess what the consequences of mercury toxicity are? You have oxidative damage to the tissues I just described. It turns out that if you're consuming a food that has a lot of mercury and very little selenium, yeah, particularly for a mother that's developing a fetus, that brain needs plenty of selenium, but if there's too much mercury, the selenium can't get there. I got into this issue imagining that ocean fish must have huge amounts of mercury and very little selenium, and I thought, wow, that explains global stupidity because people are eating too much fish. It turned out when I got into the issue, well, fish have a ton of selenium in them and very little mercury in comparison. Where did this whole problem about supposedly seafood having a lot of mercury in it come from? It turned out it was one study done in the Faroe Islands where 85% of the mercury came from eating whale meat, not fish. The whale meat has 5 times more mercury than selenium. And guess what? If you're getting 5 times more mercury than selenium and you're a pregnant mom, that could cause trouble. It did cause trouble in the Faroes. In fact, if those moms had not been eating ocean fish, which are uniformly rich in selenium relative to mercury, their babies probably would have been severely impaired. As it was, they were fortunate. They were eating ocean fish.
But even in that case, the ocean fish protected them. So even eating, but whales, of course, are not a part of seafood as it is defined in the U.S., and so marine mammals are not part of it.
Exactly. I was working with EPA funding. The majority of my career has been EPA funded.
Environmental Protection Agency.
Oh, okay, yeah. And one of their folks told me, well, the reason why we based all of our warnings on the Faroes instead of on the Seychelles, which was an island nation where they eat only ocean fish and far more, they're exposed to far more mercury, but so much more selenium, there isn't a consequence. They didn't base their findings at the EPA on the Seychelles work because there were no findings of harm. In fact, there are benefits. So you can only predict risk if you find harm. So they base their findings, their risk analysis on the Faroes. But who eats whale meat aside from the people in the Faroes?
It's a bit striking looking at some of the data, not all of the data, but a bit of the data in the Seychelles, and I'll speak for myself having looked at a little of it, showing more mercury predicts better IQs in the kids. You say, well, how's that? Well, it's a marker for fish consumption and maybe selenium. Do you have a comment, Dr. Hibbeln?
As I was listening to Nick over all these years, I think I distilled the issue is that mercury itself has no toxicity. The harm of mercury comes from making tissues deficient in selenium. Then the selenium enzymes don't work, and colloquially all hell breaks loose. Oxidative damage exists in the brain, in the heart, and everywhere else. This is not directly due to mercury. It's due to mercury binding and creating a selenium deficiency in tissues.
So if I could ask a follow-up question, and that I think I know the answer to Nick, can you recreate in an experimental system the same kind of symptoms of, let's say, mercury toxicity by simply making an animal selenium deficient? No mercury at all, just selenium deficient.
Yep. The selenium homeostasis is so excellent. The only way you can make a brain selenium deficient is adding a ton of mercury. And that only happens, like I said, if you're eating whale meat. None of the ocean fish that are commercially available will ever have a excess of mercury. However, one thing that the EPA did that was very insightful was they asked us to come up with an equation that mothers could trust, because they don't want to hear this much mercury, that much selenium. It's too complicated. They want something simple. They had us create the health benefit value, which if there's too much mercury relative to selenium, it's a negative number. We shouldn't be eating any of that type of seafood. But all ocean fish, commercially available ocean fish, have positive health benefit values. We call it HBVs, but health benefit value is the only reliable index there is of risk associated with any of the mercury exposures. And it's not a seafood issue, but freshwater fish here and there across the world can have more mercury than selenium. And so those need to be investigated, and EPA is altering its focus to looking at freshwater fish in the United States. And I've been across Europe, South America. We're talking with folks in Asia. The health benefit values in some of those places are negative. They need to address it. But ocean fish is actually the best solution if there is a population that's exposed to too much mercury. Bring them some ocean fish. It's the best source of selenium for preventing mercury toxicity.